So now let's talk about content delivery networks, or CDNs for short. CDNs are a way that we can cache data closer to end users so that we don't have to make requests across the entire world. I just realized this picture with our client being so close to the origin server isn't good. I'm going to move this. Okay, so now our client is over here. They're a little bit farther from the origin server, but they're still, I guess, floating in the water over here. Let's assume they're on a cruise or something like that, maybe on a plane. Here you can see we have a bunch of servers distributed around the world. One of these is the origin server, and the rest of these are CDN servers. The idea, as I said, is to bring the content closer to the end user. So we might have all our servers in a single region in the world somewhere, but our users are probably all around the world. So we'd like for all our data to be as close to users all around the world as possible in every region. Now here I've drawn it pretty simplified. We only have a single origin server and about 5 CDN servers. In reality, we could have hundreds or thousands of CDN servers all around the world. So they really should be pretty close to the end user, at least the majority of our end users. The downside though is that we can't put everything on CDN servers. CDN servers are pretty dumb. We can only put static content that is not changing. We can't have application code running on the CDN servers. There's sort of a new thing called edge servers that are being worked on right now and being introduced. These are newer, so we won't be covering them. They can actually allow you to run code on sort of like CDN servers, on servers that are distributed around the world close to end users, but that's kind of beyond the scope of this. And this is a very, very new development, so we're going to not be covering that for now. So if we can only put static content in CDNs, then what's the point? What kind of static content would we actually do anyway? Well, sort of what we talked about earlier was the JavaScript. In the caching example, we talked about how that JavaScript is not changing. For every user, it's going to be the exact same. And unless I actually update the original code, the user is fine to access one of the CDN servers. So that JavaScript that we looked at in the last lesson actually is hosted on a CDN. Because it's not changing, it doesn't need to hit the origin server every single time. But there's actually all kinds of static content like images or videos. Videos aren't changing, images aren't changing. If people want to see a picture of the Eiffel Tower, for example, it's going to be the same for everybody. We don't need it to be on the origin server where we're running code. It's okay to put copies of that image everywhere around the world so that when a user wants to access that image, they don't have to go all the way to the origin server. That image is already on a CDN. They can travel a much shorter distance to get that data. So it's faster and it lowers the demand on our origin server. We're distributing the data in CDN servers, which decreases the latency because it's a much shorter distance, but it also increases the availability, because what if one of these CDN servers goes down? It's okay, we can go to the next closest CDN server. So we increase the reliability and the availability of our entire system. Now there's a couple different types of CDNs. We can have a push CDN or a pull CDN. So let's say we're building an application, let's say Twitter, for example. We have our server that's going to be handling requests like creating tweets, deleting tweets, and doing all kinds of stuff. Now, one component of a Twitter profile is the profile picture, right? It's an image. So this can be hosted on a CDN. This image is static. It's not going to be changing unless a user changes their profile picture. So what we're going to do with a push CDN is, as a user uploads this image, it's going to be on our origin server, but we're also going to actually spread it out. We're going to push this data to every single CDN server immediately after it's been added to the origin server, because now we've split it up, and when clients access it from anywhere in the world, clients will be reaching the closest CDN server. They don't have to go to the origin server. So that's pretty simple. Now, pull CDNs are a bit different. It's more similar to the traditional caching example that we looked at, because with this, if a user uploads a profile picture, it will be on the origin server. We're not going to immediately push it to all the CDN servers. With pull, a user is going to make a request, and maybe they load somebody's profile and they want to see that little, circle profile picture at the top left of that user? Well, first, they're going to hit the closest CDN server. They're going to check, is that profile picture already cached at my nearest CDN server? No, it's not. So then the CDN server is going to act as a proxy. I know we haven't, gone super in depth into that, but this is an example of a proxy. The CDN on behalf of this user is going to say, well, this is a cache miss. I got to find that image. I'm going to go to the origin server. It must have the image if it exists. And then the origin server is going to return it to the CDN. And then at that point, the CDN will cache the image. And then this user will be returned that image, of course. But then any other user close to this CDN that's making requests to the CDN will also get that image. And the next time a user requests it, it will be a cache hit because now the CDN has that data. But at the same time, maybe users in the other side of the world over here, they don't care about that same profile picture. Like people in this side of the world, maybe they don't even care. They never request that same profile picture. So we never had to push that image to all these other servers on the other side of the world because it wasn't necessary. Users over here, maybe they do access the CDN, but they don't look for that exact same profile picture. So this CDN server will only have the copies of data for users around it that are actually using that data. We don't want unnecessary data. So a poll CDN would be better if users around certain regions of the world have different interests and they're using different data of the origin server. So at a high level, CDNs are this idea of moving data closer to end users, just like how in farming, maybe certain countries can farm a lot of bananas, but then those bananas are shipped to end users, aka grocery stores, where people actually can just drive down to the grocery store and buy some bananas. They don't have to go across the entire world where bananas are actually grown. Now let's take a look at a quick example. Let's go to twitter.com and once again opening up the dev tools, though this time we're going to actually be looking at the elements tab because we want to see the HTML. So scrolling pretty much all the way down, you can see that Twitter is actually using a CDN, a content delivery network. Now what this is for, it looks like it's some JavaScript and it's for handling Apple authentication. I assume it's for this sign up with Apple functionality that they have. And I'm actually going to copy this URL, this Apple URL, and open it in another tab. So opening it, you can see that this is just some JavaScript code. It's created by Apple. It's not very readable, but it's just code and it's static code. So we can assume that this is not going to be changing very often. Every user who loads twitter.com is going to be loading this JavaScript. So while Twitter could take this JavaScript and create a copy of it and then host it on their own servers, or they could have installed that package, assuming there's a package for this, they could have installed it and hosted it on their own server. But it looks like they're using a content delivery network that's provided by Apple so that every time a user opens up twitter.com, they don't have to load this JavaScript from Twitter's server. They can load it from a content delivery network server that's much closer to their own location. So going back to our drawing really quickly, assuming this is Twitter's server, we have to hit that server to, let's say, load twitter.com. Maybe there's no way around it. We have to load our own profile page and we have to log in and do all that stuff. So we do have to interact with Twitter's server. We have to go this entire distance. But if there's some data like images and JavaScript and Apple authentication stuff that can be hosted not on the origin server, we can create copies of it, static copies, and put them all around the CDN. To access that portion of data, we can just go to the CDN. So we're basically taking a large amount of data here, breaking a piece of it off. We could have hosted this data all in the origin server, or we can create little copies of it and put it all around the world in CDN server. So now we have a smaller amount of data that has to travel this entire distance, and a little bit of that data will be moved closer to every end user, regardless of where they are around the world. We do this because it's possible and it speeds things up. If we could do that with the entire data, we definitely would, but we can't because there's going to be some stuff over here on the origin server that's not static. It's different for every single user. Every time a user opens up the page, they see something different. That almost always happens when we have authentication, right? Everybody logs in and they see a different experience. They see a different feed. They see different content. That's what this is about. Now, quickly going back to the dev tools, I went to the network tab and I typed in CDN, and then we saw this Apple ID JavaScript that we looked at in the elements tab earlier. There's one last quick thing I wanted to show you. It has to do with that hash control header that we talked about earlier. So this time you can see that the cache control does have multiple values. There's max age, so 86,000 seconds, and some other stuff, but I want to focus on this public value. Cache control can have multiple values for the visibility. It can have nothing here, which we saw in the last lesson. It can be private or it can be public as well. Public means that this data, this JavaScript, is allowed to be cached on other servers that don't include the user's browser. So if there's some middle layer server, which in our case there's a content delivery network, this JavaScript can be cached by the CDN. That's what this public specifies. If this was private, that's basically indicating that this should not be cached by a CDN server. In that case, the CDN would not cache this JavaScript. But in this case, it's perfectly fine for it to. It's public, and that's the idea. This would be relevant when we're talking about pull CDNs, where from the client, we make a request to the CDN server. The CDN server doesn't have the data. Then we make a request to the origin server. It does have the data. It returns it to the CDN server. And then the CDN server sees in the HTTP header that cache control is public. Okay, great. I'm going to cache that thing. And then anytime a user needs it, then I'm going to give it to them immediately without having to go back to the origin server. So I know we talked about a lot of things when it comes to caching and content delivery networks, but if you can understand this very basic high level use case that moving data closer to users is faster, that is the most important part of all of this.